So good afternoon. So my talk is on the evaluation of a CRISPR-based diagnostic platform for fungal keratitis. So I have patents related to the CRISPR-based diagnostics for fungal infections. The unmet need in fungal keratitis is to develop a diagnostic modality which can be applied at the primary healthcare level. So our aim was to overcome this diagnostic bottleneck by developing a rapid and cost-effective point-of-care test for fungal keratitis using CRISPR, which we have termed as RIDMIC, which stands for Rapid Identification of Mycosis using CRISPR. So our two primary goals were first to develop the assay and then second to benchmark it against already existing diagnostic modalities. So this is the principle of the assay. It has two components: an isothermal amplification step, which amplifies the target fungal DNA if present, followed by the CRISPR reaction itself, which gets activated in the presence of the amplified DNA, and cleavage occurs, which is visualized as fluorescence. So this is how we interpret the results. When the fungal DNA amplifies, it triggers the CRISPR system to cleave a fluorescent reporter. So we have developed the assay for dual purposes: as a point-of-care test at the primary healthcare settings and as a PCR alternative in tertiary facilities. So the straightforward binary qualitative readout, perfect for point-of-care testings, and a quantitative measure in tertiary facilities. So the first step was to test the specificity of the assay. As seen here, a positive test was seen with all tested fungal DNA, but not with bacterial or human DNA. Both the readouts are depicted here. All tested fungal DNA fluoresce, and a corresponding spike is seen in the spectrophotometer readings. Next, we tested the analytical sensitivity of the assay. So the limit of detection was around 13 to 16 genome copies, which is similar to the LOD of panfungal PCR as reported previously. The next was to validate the assay in a clinical setting. Corneal swabs or scrapes were collected from 123 consecutive patients with smear-positive microbial keratitis from 3 different tertiary eye care centers. Technicians were blinded to the results of the conventional test. They performed the RIDMIC assay. So for the real-time readout, we set a threshold of mean RFU plus 3 times the standard deviation from the RFU values obtained from 10 healthy donors. Meanwhile, for the visual readout, photos of the sample tubes were presented to 3 masked observers who graded them positive or negative based on the color. So the concordance between RIDMIC and microscopy was 93%, 74% with culture, and 83% with PCR. So here we show the mycological spectrum of the assay. So this data demonstrates the assay's versatility and ability to accurately identify a wide range of fungal species. So the visual and real-time readouts were in perfect alignment with 100% concordance. Additionally, the inter-observer agreement for visual detection among the 3 observers was 98.6%. So being a nucleic acid detection modality, we benchmarked RIDMIC against panfungal PCR. So RIDMIC showed a sensitivity of 93%, surpassing PCR 79%. Additionally, RIDMIC's specificity stood at 89% compared to panfungal PCR 84%. The average time for diagnosis was 39 minutes with no notable differences between samples that were culture positive or culture negative. However, samples that were both culture positive negative and microscopy negative exhibited significantly longer times to diagnosis. So given the concern of fungal contamination, especially in tropical countries, we rigorously tested the assay using environmental samples from various locations, including sample collection areas and the assay's operational sites. As you can see here, compared to the positive control, these samples turn negative results, which further exemplify the robustness of this assay. So to conclude, this is the first CRISPR-based system reported for the diagnosis of fungal infections in any organ system. The sensitivity and specificity is comparable to panfungal PCR. It produces an easy-to-read binary readout. The turnaround time is less than 45 minutes, and it can be multiplexed for species differentiation.